Alright, here's the process. We could probably figure out this antiderivative in our heads, but we're going to use u substitution to kind of walk our way through it. So what we need to do is choose our u. U is a function of x. It's a part of the problem. That is your u right there. Typically u is going to be in parentheses, or to be like inside of a square root, or it might be an exponent with like a x squared plus 4 or something in it. So that is our u. So u equals 6x. So next thing we have to do is du dx equals 6. So we find the derivative of u with respect to x. And now we need to, so we should probably
do you have any hand tricks like this for finding derivatives?
choose u, find du dx, solve for dx, which is what we're going to do. So I'll multiply by dx, so du equals 6 dx, so dx equals du over 6.
What does dx mean again?
Change in x. So thinking back where integral came from, it's your delta x on the x-axis, like the RAM.
So you're taking the change in u with respect to 6?
This?
Yeah.
If you want to think of it that way. Okay, so now the only reason we did that is so that we could rewrite our integral in terms of u. Rewrite integral in terms of u. Okay, so now I have the integral of sine of 6x, that is our u, and our dx is du over 6. Okay, so evaluate. The 1/6 I can pull out, so integral of sine u du, well the antiderivative of sine is just negative cosine.
Where'd the 1/6 come from?
It came from the du of 6.
Oh dear. So,
Right?
you use 6x.
Okay, and then
Bless you.
back.
Because when you
Substitute.
solve the integral, you got rid of the du. It's just like if you're solving an integral of dx, you don't have a, like when you solve an integral like normally, like a normal integral, like you don't have a dx left over.
So we're going to write
Does that make sense?
our u now as our 6x plus c. So we could have done that without u substitution.
No, integral of sine u du is equal to cosine u. It's not equal to
And that's
cosine u du.
That's it.
Wait, so where did the 1/6 come
Right.
from?
The whole lesson?
That's
Oh, you
divided
just
by
pulled out.
Yep.
Alright, give us an example to work on.
No. No.
Alright. I'll let you try it. Okay. So
No watermelon there.
Watermelon.
No.
There's a half rest missing in
Hey,
the
you just
part of
made
the
it.
watermelon now.
What?
You just added stuff. You did it.
It's still significantly harder.
Can you use more parentheses?
okay, so step 1 is to choose our u.
All the x's turn into u's, or we have to choose specifically what is u.
So remember, u is generally a quantity.
X
It's
squared
inside a
plus
parenthesis, or it might be an exponent or a square root. So what do you think u might be?
Oh,
X squared plus
excellent.
10.
X squared plus 10. So let's say u is, and I'm gonna, after I'm done with this problem, then I'll give you clues to what you should choose for u. Okay, because right now you're like, I don't know, let's just pick that. Why can't we pick 4x? So u right now is x squared plus 10. So du dx equals 2x. If I solve for dx, I'm going to multiply and divide. So dx is du over 2x. just gonna make you chuckle every time. So it's integral of 4x, the sine of u, times dx, which is du over 2x. Now our integral can't have more than one variable,
No.
but luckily the x's cross off, and the 4 over 2 is 2, so it simplifies to be 2 integral of sine u du. I should have gotten more creative. Just keep doing sine stuff. So that is -2 cosine of u.
U.
So -2 cosine of
X squared plus 10.
x squared plus 10 plus c. Okay? No way we could have done that without use substitution right now, probably, huh?
I don't know.
You'd have to work through it mentally. Alright, so every time we choose our u, we will eventually find the derivative, and you notice the derivative we end up dividing by it. Okay? So if you find something a quadratic, know that we're going to divide by the derivative of that. The derivative of that is 2x. So you can, in your head, think, that's how I'm going to get rid of that x, because I'm going to divide by 2x. Okay? So you wouldn't pick this, because then we'd be divided by 4, and that's not going to undo sine, and it's certainly not going to undo an x squared.
What if it was just sine of x squared plus 10?
That was the integral?
Yeah.
Then it would be more difficult than this, because it wouldn't be solved using use
Can you show
substitution.
that? Don't worry about that right now.
Alright, so let's try this one.
When you try the last one?
Try this on both sides.
Do they all have like sine, cosine, and tangent in them?
Yes, every single one.
No,
of
he
them.
just can't think of anything else.
So we go from 0 to pi.
You can do like a square root problem.
Oh, hey, wait, we can use a calculator for this one.
Done.
Wait, so